for the first 3 sections of this chapter, we talked about 2-dimensional figures, right? We are finding area of flat figures. So something just sort of laying on the ground or laying on the wall flat. Well, for this next second half of the chapter, we will be talking about 3-dimensional figures, so that take up space other than just flat. Yes?
Is this going to be kind of like 2-dimensional?
Kind of like what?
2-dimensional?
Sure, yeah. I mean, it's kind of like 2-dimensional, except it's got another dimension.
Is it more hard?
Is the area just...
All right, so, oh gosh, that went way too fast. That's not what I wanted.
Ooh, nice.
Okay, Okay, let's talk about vocabulary that we'll be using to talk about 3D figures. So we call them solids because they're not flat, right? A 3D figure is a solid. It encloses a space, so like it contains volume inside of it, and it takes up 3D space. We're going to fast forward real fast so that we learn how to draw these shapes so that you can draw them in your notes. And then we'll talk about vocabulary. All right, so to draw solids. Solids are always defined by their shape of their base. Okay, so a rectangular prism will have 2 bases that are, guess what shape? Rectangles. Okay? Rectangular prism means it's got 2 of the same exact base that are both rectangles. Here's how we draw it. Step 1. Draw 2 identical rectangles just a little bit apart from one another. So start by drawing 2 identical rectangles. Step 2 is you connect the vertices or the corners with straight lines. So connect the corners with straight lines. For example, top outside corner, so like the top left corner with the top left corner. The bottom left corner with the bottom left corner. The top right with the top right. Oops, that went a little too fast. The bottom right with the bottom right. And then you dash the ones that like you can't really see. I'm not super concerned with the dashing. I feel like as long as like the book will, or like I will sometimes, like you dash the ones that like you can't really see. If this was a solid, like you wouldn't see that part, and so you draw them with a dashed line. But generally that's how we draw a 3D prism. Always start with your bases that are the same, and then connect them with straight lines, and then it makes it 3D. Okay? Okay, then let's do one more. So this is where we have a pyramid, which we'll be coming to in a moment, but we'll talk about how to draw it. A triangular pyramid will have what shape base?
Triangle.
A triangle. Hence the name, triangular pyramid. So our base is going to be a triangle. Step 1, draw a triangle for your base, and you draw a dot above it for the apex, because a pyramid meets at an apex, right? It meets at a point rather than having 2 flat bases. So start with your base, whatever shape that base is, and then your point for your apex. Step 2. You're going to connect the vertices or the little corners to the apex point. So you draw a straight line from the corner to the dot, from the second corner to the dot, and from the third corner to the dot. And now we have a little pyramid. Okay, and then you can, if you want, dash any sides that might not be seen, right? Like because it's a solid. So you can sort of dash those out, and then that's your pyramid. Oh, All right, so you can use the rectangular prism that you just drew to label, just so that we know vocabulary. We call the flat parts of a shape the faces. Okay? So like any 3D solid has faces, as long as it's got flat shapes. Okay, so like this box, this example, this prism, we've got a face on the top and the bottom. We have a face on the front and the back. And we have a face on each side. So it has 6 faces, right? 6 faces. Okay, then we talk about edges of the polygon, or the polyhedron is what we call it now because it's 3D. It is just a line segment where the 2 faces intersect. So it's like the long corners, I guess you could kind of think about it, right? An edge. Where if you had like water running across the shape, where that water would fall, right? An edge. Liam, question.
I remember learning this in 5th grade.
I love that. So hopefully this is review.
Yeah.
Good. Good. Yes, and so you may have seen this, which is great, and then probably what we'll do this year is build on it and then find the different surface area and volume and stuff. So it's good that you know the vocabulary. The last part, so you can see that little green dot, is a vertex. And that's where 3 or more edges meet. So like you can see on that green dot, we've got the side edge, we've got the up and down edge, and then we also have the little dashed edge in the back. They're all meeting to form a vertex. It's like a corner, okay? The plural of vertex is vertices. So if you have more than one vertex, you have 2 vertices or 6 vertices. So if you see the word vertices, it just means more than one vertex, okay? So we're going to take those vocabulary words. And here's our solid. Now, you can try to sketch that. Notice the shape if we want to practice sketching. This is what shape is our base? Trapezoid. So we would call this a trapezoidal prism. I'm going to give you a second to sketch it in your notes. So sketch 2 trapezoids. Make them as same as you can, right, with our own freehand drawing. And then connect their corners with straight lines. All right, let's start by identifying the number of faces on this prism. Okay, we have a top and a bottom, right? The 2 trapezoids, those are 2. And then around the edge, we have what are called lateral faces. Those mean the sides, the side faces. How many lateral faces do we have around the sides? Kennedy?
3 or 4?
4, right? Because we've got this one, 1. We've got this one, 2, 3. And then there's this one in the back, right? There's this big one in the back. Do you guys see that?
Yeah.
The back of the trapezoid. So we've got 4 lateral faces around the side and a top and bottom. So how many total faces? 6, right? All around the sides and the top and bottom, there are 6 total faces. Question or answer. Okay, let's talk next about edges. Remember, edges are the flat surface, like the flat places where it comes together. So we've got 1, 2, 3, is it? 4, 5, 6, 7, 8, 9, 10, 11, 12. Don't forget that little edge in the back. 12. All right, and then vertices, again, the plural of vertex. Now they've been super nice and have put little dots at all the vertices. How many vertices are there on this shape? With a hand. If you don't have your hand up, your voice should be off. How many vertices are there, Will? 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. All right. Move. Little more vocabulary. A prism versus a pyramid. We talked about this a little bit already because we went out of order. A prism. Oops, that went way too fast. Okay, the geometric definition, and you should abbreviate as you write this. It's a polyhedron. That means a figure with many faces, because it is a solid. Polyhedron means many faces. With 2 identical bases, right? So a rectangular prism has identical rectangles. We just saw a trapezoidal prism with 2 trapezoids, identical bases, and lateral sides that are parallelograms. So that's a prism. 2 identical bases. This is the important part. 2 bases. A top and a bottom is a prism. Okay? And they'll be the same shape for the bases. Here is our example. What type of a prism would I call this if I was going to classify it? Roger? Very good. A triangular prism. It's a prism because why is it a prism and not a pyramid? Kennedy?
Because it has 2 identical bases.
Yes. Do you guys see that? There are 2 bases of this prism that are triangles. 1, 2. 2 identical bases. And then corresponding lateral sides. Notice how the sides are what shape? Rectangles are parallelograms, right? Notice the sides. That side's a parallelogram. This bottom side is a parallelogram. And the other side is, what would you, Colin, question? Yeah, so let's sketch this because if we're going to, mine was just written for me, but if we were going to sketch this, we would draw our 2 triangular bases, right? So always start with your bases. And then connect them. This was a poor drawing. Let's try and do that again. Okay. Make them a little bit like off. Don't set them. Oh dear, this is bad. I mean, this is why it's great that I've got the copy and paste method. Yeah, right. But again, close enough, right? Close enough. If yours looks like that, great. Close enough. Okay. And a pyramid, the difference is a pyramid. Here, I'm going to just draw this back a little. Okay, pyramid is again a polyhedron, many faces. It is a solid that has 1 base. And the lateral edges that meet at 1 vertex at a point at the top. 1 point, an apex. Notice how the prism, they don't all meet at 1 point. It's got a bunch of different faces. Versus the pyramid has 1 base and all the sides go up to 1 tiny little vertex that we call the apex of our prism. Okay? Notice the lateral faces of a prism, of a pyramid are what shape? Triangles. What is the base of this pyramid, Miles? A square, okay? Pyramids can have different bases. This would be a square pyramid because we always define it by its base. This is a square pyramid because the base is a square. We could have a rectangular pyramid with a rectangular base. We could have a triangular pyramid with a triangle base. We could have a trapezoidal pyramid with a trapezoid base, right? Sure. Why not? Sometimes it does take a while to see. All right, moving on. Now we did this, how to draw them. I'm going to skip these. Triangular pyramid, blah, blah, blah. Okay. So you don't need to write this down. We talked about this, but you can use those steps for drawing for any prism or pyramid. You just always start with the shape of the base and then draw as continued. So a trapezoid, like we did, we drew our 2 trapezoidal bases and connected the vertices. For the square pyramid, we drew a square base and then we connected to the apex. So you just always start with the shape of the base or bases and connect. Let's do our last example here. Now this shape, this polyhedron, right, many faces, it's a 3D shape, is a little bit more complex than the ones we've drawn. It's got a few more faces and edges and vertices. And it is 3D, so we can see this couple front 2 parts, but there's also those on the back. So we need to take that into consideration when we're finding faces, edges, vertices. All right, Eddie, what do you want to do?
So you count the front faces and the back faces?
Okay, good. Let's do the faces first. So in the front, how many faces do we have? We've got this one on the top, right? 1, 4, 5 on the front.
And then 4 on the back.
And then we've got 4 more on the back because these ones are all also in the back. So total, how many faces do we have?
9.
Good. On this figure, this little diamond here, we have 9 faces. Good. All right, let's do the edges next. Liam, help me with the edges.
I'm pretty sure there's 12 edges.
Okay. 1, 2, 3, 4. Okay, those ones are not going to repeat at all, right? Then we've got 5, 6, 7, 8. Now, I did those ones separate because those don't double, right? Those edges all won't double in the back. Do you see that?
Yeah.
So right now we've got 8.
So 16.
Good. And then we've got this one, 9. And we'll have another one in the back. So 10. 11. And another one in the back, 12. 13. And another one in the back, 14. 15. And another one in the back, 16. So 16 edges on this thing.
But what about the 2 right there, the ones that are like...
Where? Go up and point. Of the diamond. So again, I'm going to count the ones that we can see first, and then we'll do the ones that we double last.
Just like duplicate it like on the back.
Yeah. Yep. Because this is technically 3D, so it's going to be the same all the way around, even though we can't see it. All right, let's start with here. We've got one down here, right? 1, 2, 3, 4, 5, 6. This one nope, 7, because that one's the same as this, right? 7. But then this one, we're going to have one in the back. So 8, 9 vertices. Should we do it again? I feel like there's a lot of whats.
We should do another one.
We've got 1, 2, 3, 4. Okay. 5, 6, 7. And then this one, 8, will also have one in the back. We'll have a back corner that we can't see. 9. Right?